Good afternoon. In today's lecture, we will discuss in detail the Enterprise System Development Lifecycle. An ERP development lifecycle provides a systematic approach to implementing ERP software in the changing but limited resource organizational environment. The ERP implementation lifecycle identifies the deploying of an ERP software from planning through go live. After attending this lecture, you will be able to review the system development lifecycle and its problems and alternatives, examine the key issues of ERP implementation strategy and the ERP implementation lifecycle, understand the rapid implementation methodologies, and compare the SDLC with ERP lifecycle. Know the role of people in the ERP lifecycle process, and understand the importance of the project organization chart to provide a successful ERP implementation, and finally the components of a project organization and the role of and responsibilities of each one. ERP systems are complex systems and require proper planning and total support. Either this support is from management, from employees, or end users for its successful implementation. A successful ERP implementation raises the productivity of the enterprise and results in increased customer satisfaction. A company is likely to benefit more if it's able to fully integrate ERP into day-to-day business operations of the company. An effective ERP system will be able to accommodate fast-changing business conditions. There are different technical and organizational challenges in implementing ERP systems, depending on the organization, scope of implementation, business process, and skills of the end users. The system development lifecycle provides useful guidelines to the ERP implementation lifecycle. So during this lecture, we will discuss the key phases of the ERP lifecycle and the different solutions available to overcome these limitations of implementation. System Development Lifecycle, or SDLC, is a process for planning, creating, testing, and deploying an information system. The system development concepts applies to a range of hardware-software configurations, as a system can be composed of hardware only, software only, or a combination of both. There are usually 6 stages in the cycle, including requirement analysis, design, development and testing, implementation, documentation, and evaluation. The system development life cycle is composed of several clearly defined and distinct work phases, which are used by system engineers and system developers to plan, design, build, test, and deliver information systems. Like anything else that is manufactured on an assembly line, an SDLC aims to produce high-quality systems that meet or exceed customers' expectations based on customer requirements by delivering systems which move through each clearly defined phases within a scheduled time frame and cost estimates. System development life cycle is the process used by software industry to design, develop, test high-quality information systems for organizations. The SDLC aims to produce high-quality software that meets the customer expectations and reaches the completion within time and cost estimates. SDLC is a framework defining tasks performed at each step in the system development process. It consists of detailed plan describing how to develop, maintain, replace, and alter or enhance a specific software. The life cycle defines a methodology for improving the quality of software and the overall development process. The following figure is a graphical representation of the different stages of a typical SDLC. The system development life cycle consists of tasks that are divided into phases or stages as shown in this figure. The first stage is a system investigation. First, the IT system proposal is investigated. During this step, consider all current priorities that would be affected and how they should be handled before any system planning is done. A feasibility study should be conducted to identify if creating a new or improved system is a valuable solution. This will help to identify the cost, benefits, resource requirements, and the specific user needs required for completion of the project. The development process can only continue once management approves the recommendations from the feasibility study. The main goal of the analysis phase is to identify where are the problems in order to fix the system. This step involves breaking down the system in different pieces to analyze the situation, the project goals, and breaking down what needed to be created and engaging user so definite requirements can be defined. In system design, the design functions and operations are described in details, including screen layouts, business rules, process diagrams, and other documentation. The output of this stage will describe the new system as a collection of modules and subsystems. The design stage takes as its initial input the requirements identified in the proposed requirements document from the analysis phase. For each requirement, a set of one or more design elements will be produced as a result of interviews, workshops, and prototype efforts. Design elements describe the desired system features in details and include functional hierarchy diagrams, screen layout diagrams, table of business rules, business process diagrams, and complete entity relationship diagram with a full data dictionary. These design elements are intended to describe the system in sufficient details such that skilled developers and engineers may develop and deliver the system with a minimum additional input design. The deployment of the system includes change and enhancement before the decommissioning of the system. Maintaining the system is an important aspect of SDLC, as key personnel change positions in the organization. New change will be implemented, so there are two approaches to system development: the traditional approach and the object-oriented information engineer, including traditional system approaches, which is also called the structured analysis and design techniques. The object-oriented approach views the information system as a collection of objects that are integrated with each other to make a full and complete information system. This figure provides a summary of the traditional SDLC methodology. The system development life cycle process begins when someone in the organization identifies a need, a business problem, or an opportunity. Then, a feasibility study is conducted to identify whether the new or improved information system is needed. The output of the system investigation phase is the feasibility study of the system. In the system analysis phase, the system analysts analyze in detail the information needs of the end users, the organizational environment, and any systems used within the organization. In this phase, we develop the logical input, processing, output, storage, and control plan. The output of this phase is the system requirements. In the system design, we develop the specifications for the hardware, software, and people, data resources, and other information requirements to satisfy the information needs of end users. The output is the system specifications. In system implementation, we acquire or develop and install hardware and software, test and document the system, and finally train the people to operate and use the system. The product of this phase is the new system. System operation and maintenance include convert to the new system and use the post-implementation review process to monitor, evaluate, and modify the system as needed. The output of this phase is the upgrades and revisions of the currently running system. When you are building a skyscraper, you can't switch up the design halfway through. You need to follow the original path from start to finish. But when you are building a software, that isn't the case. You can change the design, add functionality, remove things you don't want, all without harming the end product. That's the major reason why software needs a good development model to be efficient from design to launch. Rapid application development is used for this purpose, to develop prototype rapidly for testing functions and features without having a worry about how the end product will be affected. But how did rapid application development come to be? What are the advantages of adopting a rapid application development model, and how do you work on the rapid application development software? First, the prototyping consists of building an experimental system in low price for end users to evaluate. By interacting with the prototype, users can get a better idea of their information requirement. The prototype is evaluated by the end users and can be used as a template to create the final system. Some types of information system can be developed by end users with little or no formal assistance from technical specialists. This is called end user development. A series of software tools categorized as fourth generation language makes this possible. Fourth generation language are software tools that enable end users to create, report, and develop software applications with minimal or no technical assistance. Some of these fourth generation tools also enhance professional programmers' productivity. This figure showed the four-step model of the prototyping process, which consists of the following. The first step is identifying the user basic requirements, where the system designer, usually an information system specialist, works with the user to capture the user's basic information needs. The second step is develop an initial prototype, where the system designers create a working prototype quickly using tools for rapidly generating software. The third step is the use of prototype, where the user is encouraged to work with the system to determine how well the prototype meets his needs and to make more feedback for improving this prototype. Step 4 is revise and enhance the prototype, where the business builder notes all changes required by the user and refines the prototype according to these requests. After the prototype has been revised, the cycle returns to step 3, where steps 3 and 4 are repeated until the user is satisfied. The process of developing a prototype can be broken into 4 steps because a prototype can be developed quickly and inexpensively. Systems builders can go through several iterations, repeating step 4 to refine and enhance a prototype before arriving to the final operational system. When one more iteration is required, the approved prototype then becomes an operational prototype. The prototype development is a key process to develop and create a successful product. It's a challenging task to create a low-price, practical manufacturing solution in a competitive global market environment. The main benefits of rapid prototyping is to explore new concepts and ideas, to minimize the development costs on iterations, and to launch successfully a final version of the product. Enterprise Resource Planning, or ERP, covers the techniques and concepts employed for the integrated management of business as a whole. ERP packages are integrated software packages that support the above ERP concepts. The ERP implementation lifecycle is the process of deploying enterprise resource planning software from planning through go live and beyond. The ERP applications are pre-packaged software developed by commercial software vendors and custom installed for organizations to automate and integrate different business processes. An ERP is packaged software. It's very different from PC-based software packages such as Microsoft Office and other softwares that you may purchase for personal use. These are complex software packages costing millions of dollars to develop and maintain that automate hundreds of business processes in an organization. Also, these applications are mission critical, so if they fail or break down, the organization will stop functioning. For example, without these systems, a bank would not be able to serve its customers for withdrawal or deposits. Also, a manufacturing company would not be able to assemble and ship their products. The complexity of ERP life cycle process is still expensive and time-consuming, so it's recommended to ensure success. ERP systems can be organized in a big bang or phased approach, which initiates the stages of a system development life cycle. According to staged system implementation model, the life cycle consists of 4 phases, including adaptation, acceptance, routinization, and infusion. Adaptation is similar to system investigation, whereas acceptance is like system analysis, where user requirements are analyzed and accepted by the team before proceeding to design and implementation. The third phase is where the ERP system is either customized or business processes are changed to assimilate the system in the organization. Once the system is operating, the infusion or maintenance and evaluation phase gets started, where problems are fixed and new features are applied for next implementation lifecycle. An ERP implementation plan is used to create a roadmap or blueprint to meet cost, scope, and time constraints of an implementation. There are many different ERP implementation methods provided by different vendors and consultants, such as the comprehensive plan, where ERP integration plan is the most expensive, lengthy, and costly approach. It involves implementing the full functionality of the ERP software in addition to the industry-specific modules. Implementing the full functionality requires a high level of business process re-engineering with major changes in the business process and customization of the legacy systems. In the middle of the road approach, the ERP implementation plan involves some changes in the core of the ERP modules and a huge amount of business process re-engineering. The middle of the road approach is not as expensive as the comprehensive approach or as straightforward as the vanilla approach. A vanilla ERP implementation plan uses the core ERP functionality and the best practice business process built into the software. A company following a vanilla implementation will have to simplify, align their business process to the ERP system, rather than modify the software. By eliminating or minimizing the required business process re-engineering, the project cost and time required for the implementation are minimized. Methodology refers to a systematic approach to solving a business problem. ERP methodology builds on the theory that an enterprise can maximize its returns by maximizing the utilization of its fixed supply of resources. Information technology, with its increased computer power and its ability to correlate pieces of information, has proven to be the best tool for business problem solving. Like SDLC, an ERP development life cycle provides a systematic approach to implementing ERP software in the changing organizational environment. There are many different vendor-driven methodologies or approaches that use traditional ERP development life cycle or rapid ERP life cycle, such as Total Solutions, Fast Track, Accelerated SAP, and Business Integration methodology. The implementation methodologies are similar to their overall approach, but the differences come in the staging of the process steps and structure. The traditional ERP life cycle accomplishes one stage at a time and requires formal milestones approvals before moving to the next stage. In a rapid ERP life cycle, once the company is committed to the implementation, the employees in the company are empowered to make the decisions to keep project moving forward and providing the flexibility and quicker feedback loops to accommodate rapid correction as shown in the next figure. Like the traditional SDLC, which we discussed earlier, the traditional ERP lifecycle approach has a deliverable at the end of each stage. For example, a report with supporting documents that is reviewed by management, and the decision is made either to continue with the project or not is made based on these reviews. End user or people involved is critical in both SDLC and ERPLC. However, there are other variations to the traditional SDLC process. The emphasis in ERP implementation is on customization of the software as well as on changing the organization business processes, rather than determining the user requirements for developing new applications, as in the traditional SDLC. This may be seen like a small deviation, but it requires a major change in the thinking process as well as team composition and skills level of people involved in the development process. Furthermore, the ERP life cycle, as shown in this figure, iterates at much faster pace than the traditional SDLC. Next, let us discuss the different stages of traditional ERP life cycle. The traditional ERP life cycle includes the following major stages. The first is the scope and commitment stage. This is similar to the investigation stage in SDLC, which we discussed earlier. In addition to conducting the feasibility study, one of the first steps is to develop a scope of ERP implementation within the resources and time requirements. Several tasks, parameters, or characteristics of the ERP implementation need to be defined at the planning stage. Also, it's required to develop a long-term vision of the new system, short-term implementation plan, and top management commitment. The last scope area of this stage is the vendor selection process. This table shows the list of key decisions to be made for each type of scope. The gap analysis is the evaluation of the functions provided by the ERP system. The physical scope establishes which sites will be addressed, the geographical locations of the sites, and the number of users. Within the business process re-engineering scope, it identifies the current process to be refined, replaced, or eliminated, and what users, departments, or sites will be affected. The technical scope identifies how much modifications will be done to the ERP software. The resources scope defines how much time and budget is allocated to the project, and finally the implementation scope defines the modules that should be implemented and how should these modules be connected to the existing systems. Within the analysis and design stage, the user requirement is analyzed. The ERP team has first to make a decision on the software and decide on consultants and SMEs. Another key activity is to map the difference between the current business process and the embedded processes in the ERP system, or gap analysis, and to develop a long-term plan on whether to change the business process of the organization or to customize the ERP software to support existing processes. Using the gap analysis, the team must develop a design that, among other things, includes a change management plan, a list of embedded processes, user interface screens, and reports in the ERP software that will need customization, design of these changes, and a process of involving subject matter experts in the design. Other activities include creating plans for data conversion, system conversion, and training. The acquisition and development stage is similar to the acquisition and testing stage of traditional SDLC. The organization has to purchase the license for the production version of the software and build the production version of the system, which is to be made available to end users. The entire production platform must be configured and built with the necessary hardware, network security software, database, and real production data. The tasks identified in the gap analysis are executed in this stage. This includes customization of embedded software rules, data in the database tables, input screens, and reports that come with the ERP system. The focus for the implementation stage is on installing and releasing the system to the end users, also known as the go live, and on monitoring the system release to the end users. This production platform is a mirror of the development versions of the software. Errors found in the production version have to go through the help desk or support staff. Any changes made to the development version are then retested and migrated to the production system as scheduled updates. System conversions is a major activity for the new system and needs to be managed carefully. There are 4 basic conversions approaches, which will be visually presented in the next figure. As shown in the figure, the first conversion approach is the phased, which is a gradual movement of the company from the existing legacy system to the ERP implementation. This approach can take a significant amount of time, but can also be the least disruptive to the company. The second approach is a pilot, implements a small version of the final system. This pilot system is used to ensure that the final system is appropriate. It is similar to the test drive in that the system is used, but only by select areas, and its impact can be managed more closely. The third approach is the parallel, which had the most upfront cost because the ERP system is implemented and used in conjunction with the legacy system. This approach is best used when risk of ERP failure is of important concern. The final approach is a direct cutover or Big Bang. It's the highest risk approach but the most straightforward and clean. The company moves from the legacy system directly and immediately to the ERP system. This approach had the least amount of upfront cost because systems are not duplicated or run concurrently for any length of time. Training end users on how to use the new system is another important activity. The operational stage is often managed by the operation team with assistance from the implementation team. Knowledge transfer is the major activity as support for the new system is migrated to the help desk and support staff. Some implementation team members are very often hired as support staff. The other major activities are ongoing training of new customers or users to the system as ERP modules are released, as well as to take the fresh look at the change management strategy. The team has to monitor user feedback from training and actual system usage carefully and make the necessary adjustments to the change management approach. Another key activity is management of new releases of the software, and installation of patches and upgrades to the system, and managing the software contract with the ERP vendor. This figure shows a summary of ERP lifecycle phases, as we just explained. So we can see that the change management guides the scope and commitment phase through the system scope, the top management support, selection of implementation team, the role of internal employee and SMEs, the consultation role, and finally the vendor selection and contract. In the analysis and design phase, the implementation methodologies are identified and the data mapping and conversion plans are outlined. Within the acquisition and development phase, the hardware and software are specified for the new ERP system, the data conversion and loading plans are set, and the configuration are done. The go live phase include the conversion, testing, and training of new system users. And finally, the operations phase includes the support of ongoing training and the patching and upgrades of the new systems. Change management plays an important role during the ERP life cycle. System failures often occur when the attention is not devoted to this from the beginning stages of the project. A vision for change management needs to be expressed from the first stage and then revised, monitored, and implemented on a constant basis. A major role for the SMEs and other internal users working with the team is to guide the implementation team on all the activities of a change management, including direction on what processes need changing, customization of business rules in ERP software, input screen design, report design, and training, and communications plan for the end users affected by the new system. Support of top management and skills of the change management team are critical for successful implementation. ERP implementations are usually very long. As businesses grow and move quickly, there is a high chance that the requirements will change during the long time of implementation process. Here, consultants play an important role in rapid implementation of ERP systems. They provide different methodologies and techniques for rapid or accelerated implementation by bringing knowledge of techniques and approaches that have worked well with other organizations. Using scripts and wizards provided by consultants can help automate some of the more common tasks that occur during an implementation process. Now we will explain a sample of methodologies offered by ERP consulting firms. In the total solution, ERP packages have become essential to run businesses, yet ERP implementations often fail because these solutions are highly integrated, demand cross-functional collaboration, and require change management. While ERP solutions have become more matured and stable over the years, they are still difficult to implement and manage. Ernst & Young have developed a systematic way of approaching system re-engineering called the total solution. This approach has 5 components. First is the value proposition, building the business case for an ERP solution. The key decision to be made before any process can begin is to make sure that the ERP solution makes sound business sense. Reality check evaluates the organization's readiness for change, since many people face changing. It is something that needs to be expected and managed. The third component is the aligned approach, setting the right expectations that deliver both short-term and long-term value. Even if change is not easy for some, it's easier to accept when progress is visible for the organization. The success dimension is getting the right blend of people's skills, methods, and management in the team, as the key of any project success is having the right mix of people, including different skills, methods, and management in process management, change management, knowledge management, and industry skills. The last phase is delivering value that measures results and success. A project that doesn't show any measurable results during the process is going to fail. So total solution methodology makes sure that every project pays continuous value shares all along the way and helps to minimize the risk of a change. Whether your business objectives involves global re-engineering, process improvement, or software replacement, fast-track implementation methodology can enhance and accelerate ERP software implementation. The fast-track approach developed based on a matrix of 5 phases and 5 focus areas. The first phase is designed to reflect the integrate decisions regarding business redesign, organizational change and performance, training, process and system integrity, client-server technology, and technical architecture. The first stage is scoping and planning, including project definition and scope, and the project planning is initiated. The second is the visioning and targeting, including the focus areas of assessment, vision and targets, and defined as is modeling. The redesign identified the focus area of to be modeling, the software design and development. The configuration phase identified the focus area of software development and the integration of testing planning. The last stage is the testing and delivery, where the focus area is integration testing, business and system delivery. Fast Track identifies 5 areas as an individual thread to be woven into a unified fabric through its 5-phase work plan. These areas and their functions include project management, and its function is project organization, risk management, planning, monitoring, communication, budget and staffing, quality assurance. The second area is information technology architecture, which include hardware and network selection, procurement and installation, operations, software design, development, and installation. The third area is the process and system integrity, and includes security and audit control functions. Change leadership include leadership, commitment, organization design, change readiness, policies and procedures, performance measurements functions. The last area is the training and documentations, including the assessment, training design and delivery for project team, management, end users, operations and help desk, scripting of end user, and operations documentation. The accelerated SAP roadmap is a detailed project plan by SAP that describes all activities in an implementation. It includes the entire technical area to support technical project management and addresses such concerns as interface, data conversion, and authorization earlier than most traditional implementation strategies. The ASAP roadmap consists of 5 phases, including the project preparation phase, where proper planning and assessing organizational readiness is essential. To define it, there is a full agreement that all company decision makers are behind the project, clear project objectives, efficient decision-making process, and company culture that is willing to accept change. In business blueprint phase, the engineer delivers a complete toolkit of predefined business processes. During the business blueprint phase, wide scope is pointed to fit the industry-specific processes. Using questionnaires and the models from the business engineer, the business processes are documented to reflect the future vision of the business. Industry templates accelerate the process by predefining industry-best business practices. The result is a comprehensive blueprint of the process. Realization is based on business blueprint. A 2-step process is begun to configure the R3 system. First, the baseline system will be configured. Second, the system is fine-tuned to meet all of the business process requirements. Because the initial configuration is based on the blueprint, the baseline system gives a real-world view on how the business transactions will run. In final preparation phase, the R3 system is fine-tuned. Needed adjustments are made in order to prepare the system and the business for production startup. Final systems tests are conducted and end-user training is completed. Initial audit procedures are developed. In the go-live and support phase, procedures and measurements are developed to review the benefits of the R3 investment on an ongoing basis. SAP support and services are provided to ensure that the system continues to run smoothly. The online service system provides electronic support using a remote connection. The implementation assistant provides answers to most of the questions that may arise. ASAP provides examples, checklists, or templates such as a cutover plan. They are used as a starting point to avoid reinventing the wheel. ASAP calls these kits accelerators. Business Integration Methodology, or BIM, developed by Accenture Systems, is targeted for full-scale ERP projects that diagnose business integration needs, design business strategies and architectures, deliver one or more business capabilities to meet those needs, and ensure that the value of those capabilities can be sustained over time. This includes the strategic planning, delivery, and operation of technology, processes, facilities, and human performance. To achieve business integration, a team must define and implement a comprehensive set of changes to an organization, spanning environments to business process technologies and the human performance, all aligned with an organizational overall strategy. This methodology is best suited for full life cycle projects where organizations expect to involve either custom-built solutions or a blend of custom and packaged components. Also, it's used for medium to large projects that implement a full life cycle custom built-in business intelligence solutions and includes the BIM content areas that are relevant to custom solutions, planning, delivery, and operations. The planning phase is used to help an organization define applicable strategies and approaches for achieving a competitive advantage and building stakeholder value. The planning phase defines new and improved business capabilities to support the organization's strategies and create detailed plans to help the organization effectively and efficiently implement changes and realize the situation of sustained value. During the delivering and operating phases. The delivering phase, also known as the standard or custom route, translates the business architecture into a specific business capability. A business capability is the combination of human performance, business process, and technology that creates value to improve business performance. The delivering phase defines a cross-competency approach for taking each business capability from blueprint to development. The managing phase leads, coordinates, and monitors the activity outlined in the other three phases in order to achieve improved business results. This phase regulates whether the proposed business value were achieved, the projects and change journey were effectively managed, there was an ongoing alignment of context, content, and course of action, the required levels of ownership, sponsorship, commitment, and leadership were achieved, and finally, if the program sponsor or stakeholders' expectations were met or not. The operating phase operates the new business capabilities that were created in the delivering phase. Operating is based on the definition of sourcing strategy, service providers, and customers, which were established in the planning phase. The work in this phase must meet the formal service targets established in earlier phases, and it must provide feedback for improvement based on actual performance measures towards those targets. The Agile development methodology has gained popularity over the past decade for traditional software development. This success has helped this methodology migrate to ERP implementations. Here is the key reason for this success. At the core of any Agile approach is an assumption that whatever the requirements might be at the beginning of the project, they won't be the same at the end of this project. The longer the project is, the more truth in this assumption. To mitigate this situation, Agile methodologies start with a smaller set of requirements. They start small and deliver functionality incrementally in a series of releases. No single release covers all requirements, but every release delivers more than the previous one. The Agile methodology recognizes the challenges of managing technology for long periods in an environment that's frequently changing. This approach offers more flexibility and increased speed compared to the waterfall methodology. With the Agile method, rather than deal with the implementation in a linear progression, the project plan is divided into sprints or short intervals, and testing occurs at the end of each interval with adjustments being made. So the key problem that Agile methodology tries to solve is changing and unclear requirements. So by developing smaller portions of the ERP system and releasing them to users, the users will be able to provide feedback quickly on how the system meets their needs. This also means that if a requirement is missing or wrong, it can be corrected quickly. Therefore, rather than develop the entire process only to find problems later, the Agile approach allows the team to respond faster to changes and issues as soon as they appear. An Agile methodology has many different types of implementations. Two of the most popular implementations are the Scrum and the Extreme Programming or XP. In Scrum, the methodology states the following: instead of providing complete, detailed description of how everything is to be done on the project, much is left up to the team. This is done because the team will know best how to solve these problems. The Scrum methodology works in an agile, iterative methodology. However, it empowers the team, including a Scrum Master, product owner, and team members, to make decisions that will help deliver a successful product deliverable. Extreme Programming or XP is successful because it stresses customer satisfaction. Instead of delivering everything you could want on some date far in the future, this process delivers the software you need as you need it. In XP, an agile iterative approach is valued because it gives working software to the customers quickly and incorporates their feedback quickly to build the best product possible. ERP applications do not require the traditional SDLC process. ERP packages are complex with embedded business processes in all major functional areas of business. They also represent best practices by industry or area of business. These processes and functional activities are generic in nature and must therefore be adapted for the specific requirements of the company. This is not an easy course of action. It requires a full and detailed understanding of the business processes of the company, data requirements, informational flows, system access and security, integration with existing software applications, and compatibility with current hardware systems of the company. The ERP life cycle is often as complex as a traditional SDLC life cycle. However, there are also differences due to the pre-packaged nature of the software as shown in the table. Some of the key differences are including SDLC does not mention the software acquisition until the fourth stage, whereas in the ERP life cycle, the ERP software must be selected at very early stage of the implementation process. So we can see that one of the key early decisions in the ERP life cycle is software or vendor selection. Some vendors specialized in certain industries. Understanding the ERP software's functionality and the included business processes are very critical for successful implementation. In SDLC, the new application is custom designed based on the user requirements outlined from the feasibility study and analysis. On the other hand, the ERP lifecycle, the new application is bought by the organization and users are asked to change their business process and policy to take advantage of the best practice included in the ERP software. So in other words, the value in the ERP lifecycle is more towards re-engineering organizational processes and change management to improve productivity and create efficiencies with the help of built-in functionality of the ERP software. Another difference is in the role of external consultants in the ERP lifecycle. In traditional SDLC, the consultant's role is limited to the IT, hardware, software, and training, where most of the team is made up of people from inside the organization. While consultants play a very important role right from beginning to end of the ERP development through advising the organization on software vendor selection, business process re-engineering, software installation, and change management. There are also similarities between the ERP lifecycle and SDLC. For example, the feasibility stage in the ERP lifecycle is like the SDLC. ERP implementation requires scoping the project requirements and conducting a proper feasibility study from operational, economic, technical, and strategic perspective, like any other system. The new ERP system must be strategically aligned with an organization's long-term strategy and vision. Top management support will be available only when the new system fulfills a long-term vision of the company. With top management support, there is also a long-term commitment of resources for the project. The ERP implementation lifecycle is an expensive long-term investment for the company with a return on investment that is intangible and spread over a long period of time. In addition to the feasibility, other similarities occur at the conversion stage. The company can either go for a phased approach or a big conversion that replaces the old system with a new one on a fixed date and time. ERP implementation similarly requires extension data conversion, proper software testing and quality assurance, and user training and post-implementation IT support in terms of installation software patches and product upgrades. In this section, we will identify a key success factor for ERP project, that is the project management. The project management is the process of leading the work of a team to achieve goals and meet success criteria at a specified time. The primary challenge of a project management is to achieve all of the project goals within the given constraints. A project organization is a structure that enables the coordination and implementation of a project activity. Its main reason is to create an environment that fosters interactions among the team members within a minimum number of overlaps and conflicts. One of the important decisions of project management is the form of the organizational structure that will be used for the project. One of the main objectives of this structure is to reduce uncertainty and confusion that occurred at the project initiation phase. The structure defines the relationships between project management members with the external environment, and also define the authority by means of a graphical illustration called the project organization chart, as will be shown in the next figure. A properly designed project organization chart is important to project success. A project organization chart shows where each person is placed in the project structure, where individuals located closer to the top have more authority and responsibility than members located towards the bottom. Its relative location of the individuals on the organization chart that specifies the working relationships, and the lines connecting the boxes reflect formal supervision and lines of communication between the individuals. The organization structure must match the project governance. While project governance can be defined as an organization's overall process for sharing decision rights about projects and monitoring the performance of project interventions. The project owners, a project steering committee, and project executive must develop the hierarchy and define who is responsible for each system implementation component. The project organization structure is divided into several areas. The first is the project management office that can consist of many staff, and their goal is to ensure that the project is moving forward and meeting the implementation goals and objectives. In major ERP implementations, this group will consist of project executive, project managers, project schedulers, and administrative staff. The next level within the project organization is the leads that manage a project team. The leads are a direct link to the staff working on the project. They provide the input to management and coordinate team activities. Lead positions are sometimes the most difficult positions to fill on the project. The combination of management skills and in-depth knowledge of a functional or technical area is not easily found. The next level contains the teams and are divided into several logical areas, such as the functional team that is usually broken out by the ERP functional components to ensure that the cross-functional issues are being addressed, and to ensure that the data and procedures that cross-functional boundaries are addressed during the implementation. The technical area would include the infrastructure team that installs and implements the hardware and software on which the system will run, including servers, operating systems, network, and operational software. The development team will work to develop or modify the software to meet the goals of the system. This team will vary in size depending on the decisions to modify or not modify the system. The conversion team is very important. Conversion needs staff having knowledge about legacy system and knowledge about the new ERP system to convert the legacy data to the new system. Conversion is usually the most complex and time-consuming activity within the project, and also known as critical path. The retrieving of data and reporting information out of the new system has a steep learning curve. A reporting team will need to develop a reporting framework and initial set of reports that need to be included in the system implementation. Finally, the change management team will be the glue that provides the link back to the company and keeps the project in the forefront. Change management will develop both the training plan and communication plan for the project. The role is to provide a project implementation information to key areas within the organization. Change management should also use all communication methods available to them to ensure the message is getting out, including emails, web letters, and presentations. Successful projects are usually the result of careful planning and the talent and collaboration of the project's team members. Projects cannot move forward without each of its key team members, but it is not always clear who those members are and what roles are they playing. So the clear description of the roles and responsibilities of project staff is highly required to ensure the accountability within the project. Project staff will be made up of a variety of people from different parts of the organization, along with external staff or consultants. Defining roles is often used. A job description on a project will be the responsibility of the project management office. Each member of the project team will need to know what is expected of them, who they will report to, and what they will be evaluated on. The strategy used for the implementation, along with the main decisions of what implementation accelerators to use and which third-party applications to select into the overall approach. There are several areas that increase the chance of implementation success, such as: first, it's critical to have solid top management commitment, as ERP implementation addresses fundamental business operations. If senior management is not committed to the project, it will sooner or later lose backing and fail. Given the complexities of ERP implementations, it's also important to have a strong and experienced program management, where this program management is the glue that keeps the project together and provides leadership. If the project doesn't have a strong leader, it will not achieve goals within the boundaries of the scope, schedule, and cost. Along with the experienced program management, it's also important to have experienced ERP consultants. So by using people who have previously implemented the technology, the project leverages the knowledge gained and starts up the learning curve. In order to reduce the chance of unexpected and unpleasant surprises, it's good to minimize the type and number of customizations that are implemented, where any change is a chance for unexpected surprises and increase the chance of risk becoming reality. It's also important to empower team members. Along with actual implementation, it's important to emphasize training and change management. The implementation is not successful if the system is not used to its maximum extent. It's also important to have a strong post-implementation support, as the job is not done once the system goes live. Finally, effective and frequent communications will keep everyone on the same page and they give the greatest chance for identifying issues and problems early, along with preventing problems before they are allowed to affect the project. In this lecture, we reviewed the system development life cycle, both traditional and alternative approaches, and points out the benefits and limitations of the traditional and the newer approaches, reviewing the 5 phases of the SDLC approaches, including investigation, analysis, design, implementation, and maintenance, that provides the necessary background to understand the ERP lifecycle methodologies and see why the SDLC approaches cannot be used without changes for ERP implementation. The ERP lifecycle has variations from the SDLC process due to different reasons. However, the key reason is that organization buy ERP as pre-packaged software and then have to customize them, as well as change their company's business processes to implement these systems. Because ERP systems are complex systems that impact a large number of users in the organization, the implementation team will need a proper installation and change management plans. One of the first steps is choosing an appropriate implementation strategy. There are 3 routes for appropriate implementation strategy that are comprehensive, vanilla, or middle-of-the-road strategy. Comprehensive will take longer and require more resources, as opposite to vanilla, which can be quick but maybe or maybe not help improve the company's operations. Most organizations may choose a middle-of-the-road strategy because it will allow them to maximize the returns on the ERP investment. There are different ERP methodologies. In addition to the traditional ERP implementation lifecycle, there are rapid implementation methodologies developed by ERP consulting firms, including Total Solution, Fast Track, Rapid RE, ASAP, and BIM. Consultants play an important role in rapid implementation of ERP systems. Rapid or accelerated implementation approaches are very popular and require the use of experienced consultants to leverage the knowledge of techniques that have worked well with other organizations. Scripts and wizards developed by consulting firms can help to automate some of the more common tasks that occur during an implementation process. These include migration of data, identification of duplicate data, and other standard tasks. ERP applications do not require complex traditional SDLC process. The emphasis on ERP system lifecycle is whether to customize the software or to change the organization process to match these included in the software. Change management strategy, therefore, plays a very important role in the ERP lifecycle. ERPs are critical for long-term positioning and success of today's businesses. Management should not take a hands-off approach and leave the implementation in the hands of the IT staff. ERP software is mission critical, had a major impact on the organization business processes, and impact a lot of people in the organization, so they also cost a lot of money during the implementation period, while the returns are spread over a long period of time. The sense of team and teamwork affect all the ERP project implementation. It's the role of the project management office to address teamwork initially and throughout the project. It's important that each person on the project understands his role and responsibility, which helps to create teamwork and makes individuals and the project organization accountable to the project and project success. Thank you and see you next lecture.